So this is a video about pressure testing the Twitch board. It's been a great board, but I recently was contacted by another haunter who'd had a Twitch board fail after it might have experienced excessive current. This is going to be the failure point for excessive current. It's the MOSFET that handles all of the power switching for all of my boards. And while it's theoretically rated at up to 32 amps, that's really only with an integrated cooling system. Here's my setup. Okay, so first off, we have a 12 volt, 10 amp rated power supply.
10 amp power supply.
A standard Twitch board, which is the same MOSFET that's used in all of my boards at this point.
To modify the coding,
button controlled, so some really simple program.
Managed by a button.
I have it wired into a multimeter, which is set for managing current up to 10 amps.
Feeds through a multimeter.
And then from there, I have it set up to a resistive load. And so I have a 2 ohm and a 1 ohm resistor wired in series. So that's a total of 3 ohms
1 ohm resistor
of resistance. Now that should, in theory, simple math, give us a 4
push the button
amps of current.
See.
And we get 3.4, which is not too bad. So there's a little bit of extra resistance lost by the MOSFET in the system. Now I'm going to use the highly scientific method of putting my finger on the component of concern, and when I say ouch, that means that it's gotten too hot.
Here.
And see, at
really very, very manageable.
Sinking 3 amps of current, totally comfortable, cool as a cucumber, doesn't warm up a bit. Now what I've done is removed the 2 ohm resistor, and I only have the 1 ohm resistor.
So now I only have a single 1 ohm.
That should give me a total projected amps of, in theory, 12 amps, but it's going to develop a lot more resistance in the system, so we're not going to get nearly that.
Once again, put my fingers on the voltage regulator as well as the MOSFET.
And so now we draw a maximum current of about 8.5
Transiently, you can see
to 9.
Short burst of power.
And I can tolerate a
not a big deal.
Brief click off and on. Doesn't really bother me too much. But if I leave it on for any length of time, say more than a second or so, it starts getting really too hot.
So now I've replaced our resistor.
And now I've replaced the resistor with a standard wiper motor. And these are just unloaded wiper motors. And so they're really going to kind of be drawing minimal current.
So when I
with one wiper motor, I only draw 1 to 2 amps.
About
so pretty minimal. And so in order to mimic a wiper motor under load, I had to just start adding more and more wiper motors. I first went to 2 wiper motors, then 3, then 4, and then finally 5. So with 5 wiper motors, I generally get a inrush current of around 9 amps. And when I have my finger on the MOSFET throughout this, I notice that it gets hot pretty quick. Alright, to summarize the results of my highly scientific study, it seems that this MOSFET can handle brief bursts of current up to 9 amps, but shouldn't have sustained loads at currents higher than 4 to 5 amps. If you think that your device is going to veer into these unsafe ranges, then it's best to use it with a relay. I'll go into how to set that up in my next video.